and introduce our next invited speaker, Professor Brad Carter, who is a professor of physics at the University of Southern Queensland. Professor Carter is the director of the Center for Astrophysics in the Institute for Advanced Engineering and Space Sciences. His teaching background includes physics, astronomy, science and engineering. His current roles at his university include coordinating the teaching of physics, astronomy, and science programs and courses. He is supervising graduate student research in the field of stellar astronomy and planetary systems. He is leading research and development teamwork at Mount Kent Observatory and participating in science outreach. Professor Brad was educated at the University of Queensland. His first position was at the University of New South Wales in Sydney, and he has been at the University of Southern Queensland since 1995. His collaborations include working with researchers throughout Australia, the UK, and Europe, and also the USA. He and his family live in Brisbane, Australia, which is the only major city in the world that seems to have been named after an astronomer. Nice to know. It's the first time I know this information. So Professor Brad Carter, he will talk to us about an Australian university perspective on astronomy education online. Nice meeting you, Professor Brad. Nice having you in this GEHU 2020 global conference, online conference. It's nice to have you. The floor is yours.
Thank you, Hassan. Thank you for that introduction, and thank you to the organizers of Global Hands-On Universe 2020. What I'm going to do right now is just get my PowerPoint ready and make sure that everything is okay in terms of seeing the slides and hearing my voice. So could someone just let me know with some audio, because it's hard for me to see anyone while I'm giving the presentation, whether this comes through all right. Is everything good to go? Can you just tell me?
I could hear you well.
And you can see the slide?
Not yet.
Okay, we're just going to do something here. I'm going to do a quick check. Okay, here we go. This should, I hope, work.
Yes, yes,
here we go. Can everyone see that slide now?
Yeah, pretty nice.
Okay, good. Well, I will start. And yeah, this talk is about, I guess, one Australian university's view of online education in astronomy. And in particular, I guess, professional development for teachers and others who want to learn more about astronomy. So as an overview of this talk, really all I'm just going to be talking about is about the fact that online astronomy education is an enabler for people around the world, whether they're students or even teachers seeking professional development, to learn more about astronomy, and of course, learn about research and how scientific and astronomical research in particular is done. I would argue that online astronomy is, of course, a complement rather than a replacement to traditional on-campus studies. So it's part of the repertoire, if you like, that we have these days. I'll talk about USQ's experiences. USQ, the University of Southern Queensland in Australia, offers online studies for ranging from the bachelor's degree right through to doctoral studies. We have an observatory with robotic and remote access telescopes that supports our teaching and research training. And this talk is an overview of our experiences and to some extent our future plans. So we can ask ourselves, why do astronomy online? Okay, so let's begin with the benefits of astronomy for science education. Astronomy, of course, offers science education, as most would know, an attractive context for imparting scientific knowledge and all sorts of related STEM skills, as we might call them, including information technology and also material and skills of relevance to all sorts of industries, including the space industry, which is very much a global industry today. Astronomy, of course, offers instructive and, for the most part, safe research experiences. And of course, we can reach out to the community. Citizen science is a way to provide astronomy activity for schools and the general community. And I'm pleased to say in Australia, there is each year, there is a broadcast television program by our ABC, our national broadcaster, and there's Astronomy Week. And we've even had people in tradespeople discovering new exoplanets as part of their of the Astronomy Week. So going online offers many advantages. And I guess we can argue in a general sense that astronomy is mostly apolitical, as unifying and global in extent. Okay, so let's move on. So we can say that astronomy online complements that on campus. And I would argue that it can offer quite worthwhile learning experiences, despite the fact you're stuck at a computer a long way from where your teacher may be, your lecturer. It doesn't replace on-campus education. I would never argue that, rest assured. But I think what it does do is it offers a strategy for blended learning. So there are genuine synergies available by adding online education to your traditional on-campus teaching. In Australia, we've been something of early adopters in many things, including online astronomy. Swinburne Astronomy Online is going very well today, still doing many online courses for students. University of Southern Queensland was an early adopter, and a group formed in Western Sydney University that moved around a bit to James Cook and then ended up at USQ, which has grown our astronomy operations, including our online teaching. And I would argue finally that going online is about enabling students to do more rather than ever pretending it's a cost-saving exercise, okay? So it's not about saving money, it's about enabling students to do more. So what is our approach? So at the University of Southern Queensland, we have a very strong focus on online and external education. So even though there are 3 campuses in Southern Queensland, some 2/3 of our entire student cohort is online or external, and that includes engineering, nursing, all sorts of things you would expect universities to offer in the way of studies. Astronomy has actually had a long history at the university. For Australian terms, I should argue, Australia is a young country, so the 1970s is a long time ago for us. It's evolved from on-campus astronomy to online to a more blended approach today. As I mentioned previously, we offer the full spectrum from bachelor's degree to master's, in fact, graduate certificates, graduate diplomas, certificates, as well as PhD. So essentially, it's a full spectrum offering of astronomy online. We have a dedicated observatory which supports our students. It's remotely accessible via the internet, and that enables us to not only support our students, but support a number of research partnerships with people in the USA and in Europe and the UK. So we have a research capacity through our observatory and our staff that supports both on-campus and online PhD students. And I would also argue finally that it's a good idea for every university to have some form of a astronomical observatory on campus, just to remind everyone, including the university management, that astronomy is part of your university's story. At USQ, we have a School of Sciences, and that is a teaching unit that provides tertiary education, research training in science and closely related areas. And in fact, we have coordinated programs in courses in physics and astronomy, mathematics and statistics, computing and data science, and environment and agriculture. All disciplines are taught online, and even the on-campus teaching is evolving towards more of a flipped learning model for all courses. Our overall astronomy education strategy could be summarized as follows. We go for blended learning where that's feasible. We use an open source learning platform, Moodle, that no doubt at least some of you are familiar with. We go for a flipped coursework. So our classrooms are flipped in that we have streamed lectures in short, sharp chunks, modularized lectures and components. We do have live tutorials using both a classroom and a Zoom room to cater for on-campus as well as external or online students. We have online numerical and written assessments that are folded into the Moodle system, which does many things. And we also provide astronomical data analysis labs as part of some courses. So students analyze archive data for their labs. We also, of course, have cognate studies in math or mathematics, if you prefer, statistics, physics, computing. We also offer, because you need them, residential schools. So physics residential schools are offered where students actually reside on campus for a week and do intensive hands-on labs. So we don't forget about that for physics. And we also, of course, have quite a strong graduate research program in astronomy these days that complements our teaching. So I will just go to the next slide. So here are what I describe as maybe the 12 commandments as a slightly tongue-in-cheek approach of what might be a good recipe for effective online education in astronomy and other areas for that matter. So the first thing is to have all your relevant online course materials ready at the beginning of the course so that they can navigate their way through the course. They can see what's ahead of them. So as much as possible, provide whatever you can at the beginning of the semester. Also make clear the times that students can meet you online, either formal sessions or more informal connections when they want to speak to you, but it's good to advertise availability online. Of course, each course should have a structure to it with a number of elements. For example, an introduction. There is a forum for student discussion running throughout the semester, and obviously various items of assessment that punctuate the entire semester, as well as the exam at the end. Ensure that you have a welcome message, and we find that a friendly video works well at the very beginning as a course overview. And when you do have an online discussion forum, make sure it's open all semester because students will use it all the time, potentially. So that's something that is a safe, friendly place for them to talk freely amongst themselves as well as ask questions of the teaching staff. If you are obviously going to be doing recorded lectures, so you keep them short. It's not really useful to have a 50-minute lecture when a 5-minute or a 10-minute presentation on a specific topic will have much more impact. And that ideally is followed by a short educational activity to reinforce what they just heard about in the little video. State the obvious, keep your materials legal. In other words, copyright does matter, even for astronomers. And so we should all make sure that all our materials have appropriate copyright permissions, or we're using various Creative Commons material, for example. I'd also ensure that they're kept up to date, especially in astronomy. Things change fast, so it is important to keep up to date, ahead with your students, in fact, to usually know what's going on out there in the world. And of course, as much as possible, make them career relevant. And in many cases, this might be in astronomy for teachers seeking professional development to be better science teachers. Structure your live tutorials, perhaps with an overview mini lecture. I think that is always good icebreaker for the session. And record your tutorial, because doubtless there will be students who quite understandably can't make it at that time. For example, it might be a rotten time zone for where the student lives, okay? So this is what we're dealing with at the moment, I suppose. So provide and assess with some feedback or short activity early in the course to ensure engagement, so they don't sort of sit there napping for 12, 13 weeks. Make sure you've got something that's accessible and useful with feedback early on. Also set early high standards of student behavior. So it's not sort of the wild party that various social media platforms might be. A university online environment is a strictly regulated one with an important code of conduct, and we should make clear to our students about that early on and reinforce it as necessary. And of course, as much as possible, keep your course materials available as long as possible to your students who might find it quite useful after they've finished their course. And also, if your colleagues can access it, it's a virtuous circle. They can learn from you and provide information that will help you become a better teacher into the future. And finally, of course, use common sense. So they are 11 commandments, but perhaps they're more like the Pirates Codes, more like guidelines. You don't have to be too strict on yourself. Okay, moving right along. I guess what an important message in this talk here is USQ's approach to a teaching research nexus. We, as much as possible, want to bring our teaching and our research. They are highly complementary to one another. We don't want to keep them separate. We want them to be together as much as possible. So we have, and I'll just move something here so I can read it better. We have a School of Sciences that I've told you about. We also have a Centre of Astrophysics that I'm about to tell you about. And of course, our staff and students belong both to the school and the centre. So there is really no boundaries made. They are people working for a common purpose, which is education, research training, all wrapped up into one somehow. And so our staff in the school and the centre jointly teach undergraduate courses, mentor graduate research courses, support undergraduate projects, supervise graduate research staff. Another thing we do, of course, as much as possible, our PhD graduates become immediately adjunct staff. So Belinda Nicholson did a PhD in astrophysics with us. She's now a postdoc at the University of Oxford in the UK. And she is a willing collaborator with us in research. And people like her can end up being adjunct supervisors for future students. So again, you build a network of people to help with the cause of astronomy teaching and research training. Okay, I'm just going to go to the next one. And I'm going to shift my little thing here. Okay, so our Centre for Astrophysics has 4 research themes: stellar astrophysics, exoplanetary science, astronomical instrumentation, and computational astrophysics. We're also very fortunate to have a number of facilities, including our own Mount Kent Observatory in Southern Queensland, a high-performance computing cluster provided by the university that we make a lot of use of. We also, of course, have access to the big telescopes at Siding Spring in Australia, and state and national computing facilities, as well as, of course, international observatories. And I'm pleased to say Australia is an associate member of ESO these days, for example, which is great. So we have a relatively small team of academic staff and research staff, and we have a majority of part-time PhD students, many of whom are studying online quite successfully. But we also have a growing cohort of traditional on-campus scholarship winning students. So we have a nice mixture of people who are both on campus and out there in the globe. And the list of flags there is probably incomplete, but gives you an idea of the number of people who we have as either students or adjunct staff who are part of the USQ astronomy family, and we all work together. So just going next. So a research project summary, and bear with me, it's a rather long list, but I think it's useful to go through this overview. We have 5 projects in research at Mount Kent Observatory, all of which relate to PhD student research training and potentially useful for our educational activities. So Minerva Australis is about finding exoplanets, and the collaboration has a bunch of names there of universities around the world. All sorts of names there that I won't dwell on. The Shared Skies Partnership is a long-standing partnership with University of Louisville in the US. The SONG project is relatively new and is about stellar seismology. SmartNet is about finding space debris, working with the German Space Agency, the German Aerospace Center. The Global Fireball Observatory is the final project at Mount Kent. It's about meteors and, by implication, understanding asteroids in the early solar system. Then we have an instrument for finding exoplanets at Siding Spring, a new instrument which will help that instrument. And yes, astronomers are good at acronyms. Velociraptor is, in fact, an acronym for an instrument. Gala is another project at Siding Spring we're involved with, and there is the BeCool project, which is a truly international one. Then there's the Twinkle space mission, which is sort of happening into the future. And then finally, some industry engagement projects. And I think this is relevant in this context because one of the ways you can, I think, help people understand that astronomy is relevant is that it's not just about great way to teach science and related disciplines. You can also translate astronomy into what you might call real world outcomes in some cases. Mount Kent Observatory is a convenient drive from our main campus at USQ Toowoomba. It's in the Southern Hemisphere, it's the eastern longitude, of course, relatively dark skies, relatively good seeing for the Australian continent, which is not the best place in the world for optical astronomy, but it's good enough for what we do. It's an accessible place, and the site has been in use for literally decades, and it's evolved now into a remote and robotic observatory complex, which is doing astronomy and to some extent supporting space research. And for us, it serves both dual research and education needs. So I don't want to go into too much detail because this is about astronomy education or research, but I think if you'll bear with me, we'll see that Minerva Australis as a exoplanet discovery and characterization research project with a consortium, including all sorts of people in the US. It provides a great tool for research training, but also a source of data for all manner of student projects. And it also, I think, is part of the attraction for students, and they know that they're learning from astronomy from someone who also does frontline research, finding new worlds, okay? So Minerva Australis is an array of 0.7 meter plane wave CDK 700 telescopes, feeds fibers to an Echelle spectrograph in the main building, and you can look at a bunch of targets with individually or combine the light for more light gathering power. And yes, we find planets with it. And yes, we support PhD research training with Minerva Australis. Shared Skies has been running since the early 2000s. This collaboration with the University of Louisville has many faces, but in this context, we are doing work to help find planets for the NASA test mission, as well as use the facility for research training purposes for students in education, and even some outreach activities. So we have a suite of 3 instruments, 2 telescopes and a wide field camera. And yeah, again, we're producing research out of the facility. Light curve, top right-hand corner of the screen. It's Mount Kent's light curve of an exoplanet transit, helping finding new worlds, but it's also about training our students. And in fact, we have at least 2 PhD students who are not only going to become frontline exoplanet researchers, but at the same time, they're translating what they learn as researchers to become teachers and mentors of research so that they can inform their students in college or at school about how astronomical research is done. We also have a new project, as I mentioned previously, SONG, Stellar Seismology, and it's about a collaboration with Aarhus, a university in Denmark, and other institutions. And again, we have these CDK 700 telescopes and a fiber-fed Echelle spectrograph. So again, we can look at multiple targets or combine our light. First light is this year. Real Science, I think, will come out next year. And again, it's supporting our research training for PhD students. We're also getting a teaching telescope, thanks to our collaboration with the people in Denmark. So we'll have a dedicated teaching telescope on site as well to complement the research-focused instruments. SmartNet is one of our new ventures into space, if you like, so to speak. SmartNet is about the very important business of finding geostationary debris. So the German Aerospace Center of the DLR, the German Space Agency, is finding these little tracklets of things, and that photo there is about the debris as opposed to star trails. Lots of debris. The telescope is installed, first light this month, and it has dual optics in it, and it works, and it will find some debris for us, and will also support student research training in space as well as astronomy. Final project for Mount Kent Observatory is the Australian Desert Fireball Network camera. at Mount Kent, and it's part of a global fireball observatory meteor camera network. So different sites can see the triangulate the meteor. You can know where it lands, therefore pick up the fresh fall, and the find can be studied, relatively pristine find to understand the parent asteroid. So that's a great project that's expanding, and we're part of that, and we're very pleased to be working with Curtin University and others on that. And again, that has a great outreach program already running called Fireballs in the Sky with its own app. So we're pleased to be part of a research project which also has a strong educational and outreach elements. Moving along to Siding Spring, we are involved in an instrument project to look at the Doppler wobble, the radial velocity motion of stars indicating planets. And it's a bigger telescope, 4-meter aperture, so you can find planets around fainter stars. It's a collaboration with the University of New South Wales, the AAO, which is these days Anglo-Australian Optics, and US partners. And we also at USQ are part of a consortium of Australian universities that operates the 4-meter telescope now. And of course, it is supporting PhD research training. Velociraptor is coming. It'll be an auxiliary telescope to the AAT, and the idea is really quite simple. It's a 0.8-meter telescope that will look at objects when the big mirror is looking elsewhere, and we can still use the Veloce spectrograph. So when the AAT is doing, I don't know, galaxy studies, we can use the Veloce spectrograph with a smaller telescope to do certain survey science. So that's really happening in 2021. And again, we'll be all about supporting our research student training. Gala is a galactic archaeology project, Australian-led, UNSW, University of New South Wales, in other words, Australian National University, Sydney University, others are really the drivers behind Gala. USQ is, however, part of the story. So it uses an instrument called Hermes. Hermes is a fiber-fed multi-object spectrograph. And what does that mean in English? Really, it just means that it's a collection of glass optical fibers from various points in the focal plane of the telescope that go to a spectrograph. So you can look at 100, 200, 300, 400 objects simultaneously and get a spectrum. It's being used to do studies of the oldest stars of the Milky Way, galactic archaeology, and hence the acronym GALAR. It's getting spectra for 1 million stars, lots and lots of data. And again, we have PhD students involved with GALAR to do their research. And of course, being Australian, Australians are never far from a sense of humor. Galar is also an Australian bird. And I should also point out, in the Australian vernacular, Galar is sometimes used to as a silly person. So if someone says you're a Galar, I'd be careful, because it might mean they think you're either a bird or a silly person. Okay, anyway, so Galar in this context is just astronomy, of course. Next up, BeCool, which is about the magnetic fields of cool stars, a long-standing, I think, 14-nation collaboration in which USQ and Australia has a role. It's about stellar magnetism activity, dynamos, winds. At the heart of the BeCool collaboration is the use of taking the spectrum of a star in polarized light, spectropolarimetry, to observe magnetic fields. And so we can do really cool stuff, like doing tomography of stellar spots and also stellar magnetic fields. And then we can model using a code adapted from solar research to model the winds of of stars affecting planets. So you can literally do space weather studies for exoplanetary systems using this technique. So we're part of an international project that does that these days. And of course, it is a great source of PhD research data. So we have a number of students who have been ZDI, Zeeman Doppler imaging students, part of BeCool, which is great. Okay, final research project is the Twinkle space mission. This is in the future. Launch should be around 2024, I think. Space telescope, 0.45 meter aperture. It will be a UK-led project, of course. Blue Skies Space, which is a spin-off from University College London. It'll do exoplanet atmosphere spectroscopy, It'll look at solar system objects, especially asteroids. Mount Kent is part of the project now and will be providing ground-based support. And in this context, I think the most interesting thing I can say here is that we also want to transplant the very successful Twinkle education program to Australia. So very briefly, Twinkle is about analysing data to learn how astronomers will use Twinkle data to do spectroscopy and understand exoplanet atmospheres and look for biomarkers and all this kind of stuff, right? So Twinkle is a schools program run successfully in the UK. And I'm very pleased to say that the person who started it and ran it is Laura McKimmish, an Australian who's now returned from the UK to Sydney. She's at the University of New South Wales. So we are all talking about planning to bring Twinkle to Australia. Okay, first of two industry engagement projects I think are worth mentioning. The first here is in fact, all thanks to Carl Pennypacker. And given the time of night it is in California right now, I dare say Carl is not on the line, but a big shout out to Carl because it was his work on supernova detection work and the algorithms for automatically finding exploding stars that have led to what we regard now as the world's most effective early wildfire detection software. So this is a machine learning approach which uses data fusion from various sensors to look for fires, bushfires in Australia, wildfires more generally. And we're also, of course, talking about a dedicated satellite. So what's interesting here is essentially astronomy, classic case of astronomy giving birth to a really potentially world-changing technology. And the other example I mentioned that's come from Australia, of course, was a lot of the work done for Wi-Fi was done in Australia by someone studying black holes. So black hole research for a radio astronomer translated into really useful Wi-Fi that just about all of us use today. So this is a project that we hope to enable students to do PhD master's project with, including transferring their astronomy skills to something as absolutely real world impact is fighting bushfires and wildfires. And finally, we have what you might call a science fiction company, as some describe it, called Neora, and it's about Near-Earth Objects Resource Atlas. It's a project which is now being internally funded by Australia's CSIRO, Data 61, which is the machine learning unit in CSIRO, Australia's major research organisation. And that is about using machine learning to analyse data from space surveys, astronomical surveys, to learn more about the potential resources for explorers and perhaps even an industrial scale use one day. And that is in fact supporting some R&D across the country, various PhD projects. Okay, so I'm nearly finished. And I guess what I would say is I'll just overview the results. For reasons of privacy, I probably can't share much in the way of numbers. So I'm sort of giving you my interpretation of the numbers in terms of enrollments and other things. But what I can say in summary is a Bachelor of Astronomical Space Sciences, which is relatively new, it only started as an online BSc a few years ago, has so far resulted in strong enrollment growth. And I'm pleased to say that's more than what you might expect, which is students switching from a traditional physics major to an astronomy one. We have created genuinely new enrollments in having a degree, which is essentially a superset of a physics degree with added astronomy and space. So the enrollments are healthy, and we do preserve the residential schools and other means of delivering prac work so that they still get a physics degree which can be accredited in the normal way. And student feedback has been very good, so above average to excellent. So we think we're getting it right. There's a Master of Science, which is offered online, and it is 2/3 coursework, 1/3 research. It is really about professional developments from graduates from a fairly wide range of disciplines. So if someone is a teacher and they want to become more of an astronomer, this is for them. And the only thing we'd say, though, is when you do a master's degree with us as professional development, if you ended up in the PhD program as a result, you would, and it would be expected that you would do astronomy education if you're a teacher, or computational astronomy if you're a computer scientist. But we don't want to be too prescriptive. We just make it clear that without a bachelor's degree in a certain discipline, that to some extent dictates the sort of the research project you might be doing. The enrollment is modest, but I guess it's never really been designed to be a major big program, but it does, the enrollments appear to be sustainable, and the overall feedback from students is strongly positive. And finally, I would note that if someone did have a physics or astronomy degree, they would not actually do our Master of Science Astrophysics. They would most likely be expected to do a more traditional Master of Science research. So we do essentially have two parallel pathways, one for professional development for teachers, for example, another for someone with a physics or astronomy bachelor's degree. Finally, the PhD in astronomy, again, it's on campus, it's online, it's 3 years full-time, 6 years part-time, as is standard. We have experienced good growth there for our small group, more than 20 students. In fact, it's well over 20 with more coming. Some 2/3 of them are online. We have essentially reached staff capacity, but I'm pleased to say we have 2 new hires coming to us from the US at the end of this year, all going well. And of course, we remain to our core. The core is stellar astronomy and planetary systems research. But we are able to, through our network of adjuncts, offer other areas. And we've had a number of outstanding graduates in the history of astronomy go through, whose expertise has been developed by our adjuncts. So I think, you know, you can say this is a success story. The thesis by publications published in leading international journals. Completion rates of students is excellent. Student feedback, I'm pleased to say, is very good, as are the graduate outcomes. Given we have only a limited number of scholarships available, it's now actually becoming quite competitive to enter into the program. I'm pleased to say USQ does offer full tuition fee scholarships and even stipends. These are fiercely contested, and what it does mean is we do have students who are very, very keen and doing very well in our program. So we're obviously very pleased about that. Anyway, so what's next? Okay, well, I've told you some of our plans in terms of what's happening at Mount Kent and elsewhere, but more generally, I think the point here is that we are always been a group that has been partnering with others. It has all been about collaboration. And, you know, our success in research has really been through collaboration internationally as well as within Australia. We are, however, quite happy to talk to people about expanding what we do. It could grow enrollments. We're happy to share in whatever way that will work so that more people can benefit through online studies. I guess I would argue that given the global nature of astronomy, modern communications, and of course with COVID-19 putting a lot of us onto online work and study these days, a more shared approach is perhaps quite timely. And finally, I'd note here that given the advent of the Australian Space Agency in the last few years, and a focus by the Australian government on developing of our local space industry, we're also very keen to emphasize the space aspects of what we do, not just the astronomy. So finally, to sum up the whole talk, astronomy, including astronomy education online, has supported ongoing growth in the physics and astronomy discipline at USQ. And going online, I would argue, is not about saving costs, but is about enabling students to do more. Our educational activities are complemented by an astrophysics research center, and of course our observatory, which has remote access from robotic telescopes. And astronomy education can, of course, embrace the online world, as we are doing right now, and bring benefits to many. But of course, it won't and should not replace on-campus traditional teaching. And finally, I would suggest that whether online or taught face-to-face, astronomy can bring us a new and interesting scientific perspective, including guiding us in the grand challenge, I think, for all of us in ensuring our planet Earth is, in fact, remains a habitable world. Thank you. I'm done.
Thank you, Brad, for this interesting talk and the exciting programs you have, the exciting online program for astronomy. I think it's quite interesting especially in this time of COVID-19. I think you were really prepared to to face it. Not like other universities, they have to adapt and do some fast adaptation to move to online. I also found from your talk that we are both on a common project, which is the Global Fireball Observatory run by the Curtin University. So we do have an all-sky camera on our campus here in Morocco. And I'm glad actually to be partner somehow with you in this. Yeah. We do have two questions from the public. So the first one is from Sohan. It says, will independent researchers and amateur astronomers get to use these telescopes and other devices? So it means your telescopes.
Possibly. We would love to share. It's just that there are practical limitations. I guess the best thing I would say, I'm happy for people to contact me. So if there is some possible program or collaboration or partnership we could do, that might be an effective way to do it. Sadly, we don't have a lot of resources to share with the world without getting more resources. But I think happily we would work with people, for example, to apply for grants or look for funding to support initiatives. And we would happily, for example, demonstrate what we can do before people decide to go down that path. So we'll say possibly, yes, we'd like to, but we just have to be practical about how much we can share, because we don't quite have the major resources of a big university, but we would happily talk with people about that option, and we'd love to. We can also share the technology that's been developed over some years. So Shared Skies Partnership has in fact developed as a completely open sourced approach to robotic and remote access astronomy. So all the source code for that is available, is freely given away. So others could set up their own facility should they choose to do so. I see another question about sharing the presentation. I'm happy to do so. We'll just have to work out how best to do that, because that is such a big file full of graphics. It's not just so easy to email it, but yes, it's some way we will happily make the PowerPoint slides available for everyone to have a look at them. That's fine.
Another question from Francis Emeralino. I hope I'm saying it right. Thank you, Brad, for the talk. I would like to ask if the master's program is being offered internationally. If yes, will a bachelor's degree in applied physics be enough as a prerequisite? Thank you.
Yes, to both. In other words, the master's has always been offered internationally. The fees, there are tuition fees that apply for the master's degree. They're subsidized for Australian and New Zealand residents, but not for international students. For someone with a background in physics, there may be an alternate route, which is the one I mentioned at the base of the slide, a Master of Science Research, which again is offered online. So to give a simple answer to the question, yes, there is a way for students internationally to enroll in either of our master's programs. What I can't guarantee, though, is that they will be free, because unlike the PhD programs where we have some scholarships available, master's has no scholarships and people just have to pay, sadly. But we do offer it online, and it works quite well as an online program in our experience.
Another question from Vasilios Spathopoulos. I hope I'm spelling it right. Thank you, Brad. Just a quick question. Do you use Planetarium software for your online teaching? And if so, which ones?
We don't much use Planetarium software because in a sense, we ask students to identify a program that suits them for their teaching, but it's not an accessible item. What we do, though, have is essentially the effectiveness of a planetarium program built into the software for our telescopes. So effectively, we can provide that. No, we don't prescribe a planetarium program. There are a few really good choices out there. And if our students use it as part of their studies, then they're most welcome to. But I'll take that question on board, because if people want to essentially incorporate learning to be an expert with the planetarium program as part of the studies, perhaps we should make that a more formal part of what we do.
Yeah, I don't have any other questions. Panelists, do you have any questions for Brad? If not, I have a question. So I think you've been running this programs for a while now, and you've been teaching people or students who are 100% online and others who are 100% on-site. Have you seen any difference in the performance? Which is better? Did you have ever an evaluation of how impactful is the online and so on?
Yeah, okay. So it's not like better or worse or anything. The difference is as follows. Online is, let's face it, harder to study because you're separated, you're not in that community. So, you know, education, of course, is still very much a human activity. And so if you're in a on-campus environment, then I think you are naturally engaged in the class, what's being taught, and your classmates. What we find online is essentially there are, in a sense, two types of students. They are either students who want to try something and find that it's not for them because it's hard to become engaged. And we enable them to do some studies and decide, no, they'd really want an on-campus alternative, and that's fine. So that we have we structure our program so that they can try some studies before they decide to go all the way to, say, a master's. And then we have a group of students who are incredibly dedicated. They are so motivated that I'm not sure I'd say they outperform our on-campus students, but they are incredibly engaged. And so they have, in a sense, overcome the hurdle of learning online, of being at a distance. And because we're heavy users of Zoom, email, telecommunications, we've not only maintained, I think, success with those highly motivated students. You know, if they're wanting to study, we will teach them, right? But it also applies more generally to our group. In other words, our research team really is global. We literally have weekly meetings with people in all parts of the world. So in a sense, our students benefit from the fact that we are naturally an online group and don't care too much about distance, and to some extent don't care too much about time zones. We make things work. And I think our students benefit from the fact that we make ourselves available at all manner of hours, and that we're very responsive and we're very good at using video conferencing. So we offer, in a sense, the next best thing to being there, with the obvious limitation is we can't drink coffee together except when we watch each other on the screen and we drink, and that's all we can do in those cases.
Yeah, you've mentioned also that you adopted blended learning,
Yes.
and then also you said lately you tried to include also flipped learning. Can you give us an example of flipped learning in astronomy? So how does it go?
Yeah. So flipped learning for us is things like having our lectures canned. So we record lectures as nicely as we can, package them into small chunks, and then we populate our course with those small little mini lectures. The tutorials, though, are really this place for live interaction. And so that's where the student is more engaged because they have been given something to do, right? So rather than rely on expecting a student to passively absorb a long lecture, which they don't, right? The reality is they won't. You make them small segments. Ideally, you have a little activity after it to say, watch the video, then do this. So that means they watch the video. And then you also have these live classes where there is a classroom, there are people, there's a screen. So there are people out there in Zoom land who are also, as much as possible, feel as if they're part of the class. And it's
recorded. Is it the HighFlex system? It's called the HighFlex system.
Maybe I don't know that name.
It's a new, like a new jargon for online.
Okay,
it's called HighFlex.
We didn't know what it was called, but I think
flexible.
Okay,
flexible learning.
Now I can put a name on what we do anyway. Yeah, so that's what we do, and I mean it works. Again, we don't pretend that we can offer a complete replacement for on-campus education, but I think it's sufficiently powerful argument these days to have an online addition, shall we say, a complement to add value and just reach a lot more students that can't otherwise get to campus. The other thing briefly in passing I'll mention, I probably should have put it in the talk, but I'll mention it now. We also have a collaboration with something called the School of Astronomy and Astrophysics, which is morphed into the Online College of Advanced STEM. And this is literally an online high school venture. So it's run by David Platts in Queensland. And for more than a decade, he's taught astronomy, physics, math, all sorts of things online. And where he's really found benefit for students is a lot of students in regional parts of Australia that don't have access to a really enthusiastic astronomy teacher. They can learn online and enhance their high school learning. And it's actually fully accredited by the Queensland government. So again, what David is doing is not replacing traditional face-to-face teaching, but he's adding to teaching by providing an online version of classes for especially gifted and talented students who go on to win scholarships to universities. So I guess the message is David has demonstrated already for high schools as well as universities, online astronomy can work really well.
Yeah, I know some colleagues from Morocco who are doing some online, preparing some online programs. I've seen our flag actually in your presentation, so I guess you have some students from Morocco. One of the dilemma actually of online teaching that we faced last spring because of the COVID is the evaluation. So how do we evaluate our students, how to make sure that they reach the intended learning outcomes and so on?
Yeah. So the one thing that USQ and other Australian universities have been wrestling with is exams. So some universities in Australia have gone for online invigilation, ProctorU, for example. USQ has not gone down that path, but instead essentially provided online take-home exams. So effectively, we've switched for the time being to extended online take-home exams. You download them as a student, you do them in a day, you upload your response. It's a different exam, right? It's not the same exam. It's designed around open book examination. And early indications is it works. It's a lot more work for staff, okay? But if the staff spend the time, it does work, but we won't keep on with it because we still, again, prefer when things go back to normal, we hope to return to exam centers around the world that we use so that we'd have that fail-safe method, if you like, where there is a person in a room supervised by another person to do an exam in a time. We still want to go back to that when we can.
Yeah. Well, I guess this is it. Let me see. Maybe a last question. Are all your teaching faculty, are they like on site or they are worldwide? So they are anywhere in the world and they offer online courses?
So our faculty are on site across 2 campuses. But for some months, in fact, since almost the beginning of the year, we've been working from home, most of us, part of the time. And that's worked remarkably well. Our adjuncts, of course, are around the world. So we've never seen them on campus. And in many ways, they work as closely with us as our on-campus staff. So the good news is, although we work on campus, we can work across 2 campuses. We have an inter-campus bus, and we use Zoom and email and all that sort of thing to communicate very, very effectively with our external adjuncts who are literally global.
Right. Thank you, Brad. It's really an enriching presentation, and I personally learned a lot.
Thank you very much. And apologies, there's only 7 minutes for coffee break before the next talk.